Hello everyone, Mohammed here, and welcome to the second section in our Java course, Introduction to Java Language, and it will be in two parts. Part 1, what is Java and how it runs everywhere, and Part 2, Java as a platform, and let's start with Part 1. First, what's Java? Java is a programming language and a platform. That's what you will find when searching for Java definition. But what does that mean? So let's begin from the fact that Java is a programming language. Java is a programming language, and as any programming language, it is used to make applications. But what makes Java widely spread and popular is that an application written in Java can run on all platforms, as Windows platform, macOS platform, Android platform, and much more. While that's not the case for programs made with programming languages rather than Java, where many programs will have a version to be installed on Windows and another for Mac devices and another for mobile phones and so on. But wait, don't say then Java is an interpreted language, and also don't say it is compiled. If you remember what we have discussed in the previous section, that compiled languages have the advantages of high speed of running, since translation or say interpretation to machine code is done only once. And what runs on the computers is the machine code file, so it runs at high speed. Also, security of your source code, where compiled languages make your source code private, where when you wanna make your program available on the internet to be downloaded or wanna send it to a client, you just only upload or send the compiled file written in machine code, which is not readable or editable by human. But they have a disadvantage, which is they are platform dependent. Means that an application compiled to run on Windows platform cannot run on Mac platform or even mobile, and the vice versa. And on the other hand, we have the interpreted languages, with the benefits of platform independent, means that an application written in interpreted language can run on any platform, since there will be a software or a program on each platform that interprets what's inside the source code to the computer language, where that software or program is the interpreter. But also there are disadvantages, as the source code is public, since the file that runs on computers is the source code file, which of course readable and editable by human, since it is in high level language. Also, interpreted language programs runs at low speed, since translation or interpretation to machine code is done every time the program runs, and it is done line by line. But Java is different. Java gains the best of both worlds. It runs at high speed, and source code is private, and also it is platform independent, so it runs on all devices. So Java is neither compiled nor interpreted, but it is both. So let's see how Java works, so that it gains all of those advantages. First, the Java source code file, which has extension .java, is compiled as any compiled language. But what's different is that the compiler is one that is specific for Java, called Java compiler. And the output of that compiler will not be file written in machine code, as in normal compiled languages, but instead it will be written in a language called bytecode, with extension .class, but it is not low-level machine code, and also not high-level source code, where it's considered as an intermediate language, which is not readable by human, so we gain the advantage of compiled languages of making our source code private. And what runs on computers is not readable by human. But wait, it is still not readable by computers, since it is not low-level machine code, but instead it is an intermediate one. And now we can consider Java as an interpreted language. But that compiled file with extension .class and written in bytecode language will not interpret it using normal interpreters, as we do with interpreted languages, but instead it is interpreted using something called Java Virtual Machine, or for short JVM. If you remember from the previous section how we run interpreted languages, where the interpreted language source code file enters the interpreter, which translates or interprets that source code into the machine code specific for each platform and runs the program. Where the same for Java Virtual Machine, it will take the Java bytecode file and interpret it to the machine code specific for each platform and runs the program. And we have a Java virtual machine for each platform, So we have a Java Virtual Machine or JVM for Windows and JVM for Mac and so on and so on. And each Java Virtual Machine or JVM will interpret the bytecode file to the machine code specific for each platform and run the program. The same when we have a Microsoft Excel file and want to open it on different devices or platforms as Windows or Mac or even mobile phones, where when we create that Excel file, we don't care on which platform it will be used, as long as that platform will has a Microsoft Office application installed on it, so that the Excel file will open on that platform. However, the Microsoft Office application itself is a platform dependent, means that Microsoft Office for Windows is different from Mac and mobile. But okay, we may want to get a version of Microsoft Office application for each platform just once, but what we get in return is that the Excel file itself is platform independent, as long as there is the Microsoft Office application on any platform. And now we can open that Excel file on any platform. And the same for Java Virtual Machine, or JVM for short. We may have a unique version from the Java Virtual Machine for each platform, but what we get in return is that we can now run the same Java compiled file or bytecode file on any platform, only through that Java Virtual Machine or JVM. But wait, didn't we say that Java is not that slow as interpreted languages? How is that? Since we still can see that bytecode file will encounter the step of interpreting. But no, it is not the same as interpreted languages, thanks to the bytecode, which is now not high-level Java code, but instead it is now an intermediate code, needs the low-level code of the computers, so the process of interpretation is easier and faster than normal high-level code. And also another reason for its speed, which is a new approach added to Java called Just-in-Time Compile, or for short JIT Compile. But don't care about that for now, but all we have to know is that the Java Virtual Machine, or the interpreter for simplicity, is what makes Java fast as well as platform independent, so it runs on all platforms. But a question now, how to get the Java Virtual Machine installed on your device to run Java programs? And that will move us to the second fact of Java. That Java is not only a programming language that is used to make applications, but also it's a platform that runs those applications. But let's continue in the next video. So see you.